is something decreasing when how much is something decreasing by when x equals this?
Can you write it down? Can you write some things for me? Read. Oh. Are you studying statistic or?
No.
How much is angle decrease? Is this a topic? This is a problem, right? When the length. So you're talking about the angle, right?
It can be anything. Like this can be anything. It's just those topics where something is like moving, but we have to figure out the rate it's moving by when something.
Well, what is movement? Is a straight line, circular motion? What type of motion? Circular motion?
I think it can be anything but straight line, maybe.
Parametrical equation. So this angle, I can draw the angle, but this is 3 meters. What? The length? What is the length?
Okay, so this is a question.
This is question. Oh, this is question.
No.
All right, this is question. No.
Yeah, I'll show a question. I just want to learn how to do questions like this.
Length and angle, right? The length and angle.
That's just an example. It's like something already has a rate, but then we have to figure out that rate at a different time. Can I share a picture?
The rate, okay. Due to the rate, yeah, you can show the picture. One moment, you can certainly. I stop sharing. I can show the picture. The rate, yes. You can show your textbook.
So this is a picture I took of a question.
Meter cubic, the rate, the volume, you see the tank, the volume. This application of the calculus, the tank, the rate. Yeah, so the tank is determined, so it could be the cylinder, right? If the cylinder and the level of water will drop, if you draw the hole here, do you see that at a certain rate, right? Tap water. So you can either how water flow into the empty, that is just water into the container, all right? Doesn't matter, they at a certain rate. Yes, that's right. That's flow rate. I know what it's called the flow rate. Flow rate, right? Flow rate can be, you can use any number. Can we call this flow rate? Can we just use F, right? Flow rate is in the unit of the volume per se. This is if this volume, that would be the unit of F will be meter cube divided by second, right? Or they use hour, doesn't matter. Anyway, and also you can either use, so this is unit, can you see? This is the unit, so this is the unit for the rate. Okay. Unit for the flow rate, right? So height is not distance, the height, right? What is the shape? The cone is a cone, all right? It's a cone. Inverted means upside down, like the chocolate, right?
Yeah.
Yeah, you have to visualize this by that. So therefore, the height, can we use the x? Can we use the y-axis? We can use the y-axis. So basically, the level, so water level will increase. You see? So can we just start from 0? Can we call this y? So therefore, this 0, can you see the water will starting to build up. Oops. Can you hear me?
Mhm.
Where's
Yeah.
my drawing? I can't see my drawing here.
Oh. Mhm.
So basically, this is question. So if the water keep at a certain rate into this container, water container, which is a cone, inverted cone, the height of the cone is 10 meters. The total height is h, right? The maximum is rate. And water flow into the empty tank at rate. This is rate, okay? The given rate. And for flow rate, and how fast is water rising? So therefore, they need to ask you how fast this h is constant, right? H is I mean, it's y here. This is y. So they will ask you how fast y change. So that is so this level is an increase. Can you say at a certain rate? So this rate it can be written as dy dt. Can we?
Yeah.
So they are asking for this rate if the water is coming, say, from another container, right? If water from other container drop in, yeah, that is the question. So this is a part of application of calculus. Okay. And at a tank, they are asking for particular height, right? 5 meters deep. So basically, when can we use this notation? When y equal to 5 meters, can you see? So this is question. This is question.
Yeah. So how do we solve that? Yeah.
You go to whiteboard. I know the question now. Yes. Yeah. This is let's go to whiteboard. Where is that? Yeah, it's go to whiteboard. So this is let's just redraw this diagram before we go. So if you give me a few seconds, redraw this diagram. So basically, we are dealing with height, water height increase. So this is y. One moment. Okay. This is y-axis, right? A container is a cone, inverted cone. So this is a container, right? It's easier to draw diagram here. And then we can draw this, this is a cone, and this is a water container. So we given that water is coming, so this water is coming at a certain rate, okay? This flow rate is given. Can we see this is, they have the rate, can we divide the rate? So this is y. Before we go, this is the total height is 10, right? They're asking for the water rise at this halfway, is 5 meters, right? So this is y is in meters. And they are looking at this case, how fast the water level change, can you see?
Yeah. So
basically we have to work out the dy dt, right? Find the formula first. This is 0. Okay, how can we solve this problem? Because every time this zero increase, can we just this is you can do another at any position, right? The level will increase at this rate, but you have to convert that into this shape. Okay, so this is, can we just do another diagram to help you? So basically you have to work out, this is a cross-section diagram. So we are looking for this, we know that. Can we find the volume formula first, right? Can we find the volume first? So what is, so this, if this is y, this is 0, okay? This is cross-section. So this at any y, this at any y. How can we work out this volume first? Because we know this volume is changing, the water volume is changing. Can we just highlight that? We are not, we are calculating the water, right? So we are calculating the water level is changing. But how can we work out the volume in the first place? So what is the volume at any y? Do you want to try to think? What is the volume of this cone? And here we probably have to put another, can you see? This is x-axis, right? This probably, that will help you. This is x-axis. So at here, so this is x-axis, is origin. Okay. How can we work out this volume, please? Do you remember the formula for the cone? Volume formula for the cone?
No.
1/3 of the cylinder. 1/3 of the cylinder. So the cylinder, so this is a cone. So can we just highlight this is a cone is equal to 1/3 of the cylinder. Okay, cylinder. So what is the formula for cylinder then? So if this height is y, if this height is y, what is cylinder formula?
Pi RH.
Yeah. No, that will equal to this area. Can you see that will equal to this area? How can I find this area? Do you know this area?
Is it pi r times h?
So that area, so this area will equal to, can we just put 1/3 here first, right? And the cylinder is height. The height is y, do you agree? Height is y. And the surface area is pi x squared. Got it? So in this case, y and x, what is the relation between y and x? I mean, do you know this function? Otherwise, we have two variables. Do we know this function?
Yeah, so
did you give the diameter? Not yet. Do you know the diameter? Do you know the radius of this container?
I think that's 10.
No, the height is 10. What is this diameter, r? Do you know this r? Can you check the question?
It's 5 meters.
5, all right. So they must give it to this one. So it's 5 meters. So in other words, can we draw this diagram? I should be able to solve this now. So this is at the top. This coordinate is 0 and 10, right? How about this coordinate? Can you write down this coordinate? Can you write down this coordinate? This one. It's radius. Do you agree? This is radius.
Yeah. 510.
510. Okay, 510. In other words, we know this height is 10. So how can we work out the relation between x and y? So this is x, in this case, this is x, and this is y. So this in this triangle, how do we know this relation between x and y? Can we use different color to highlight this triangle? You see, in this right angle, what is the relation between x and y? We need to eliminate one variable before we go further. Three. Yeah. Yeah, what is the relation between x and y?
Oh.
Where's 30 come from?
Oh, that's 3b. Sorry.
Yeah. Well, you see, all of them are time constant dependent, right?
Mm-hmm.
And we unfortunately we have 3 variables. That is the question you didn't solve. We got v is changing, can you see?
Mm-hmm.
Y is changing when water is coming, right? And also X is changing. Now, what they are looking for in this question? So what they say, if the volume change, so basically the condition. So this condition, if you just look for the, so given this condition, if dv dt equal to what is number, what is rate? Do you remember?
2 meters squared per second.
Square per second, cubic.
2 meters cubed.
Yes, two, right? It's 2, right?
Mm-hmm.
So this given is no, and they ask you find what is the dy dt. You see,
Mm-hmm.
that is the question. However, we got the additional variable x. How can we solve this puzzle? So this is unknown. Dy, we're looking for this rate, right? We need to find this rate.
Mm-hmm.
How can we reduce the variable to 2? Oh, you want to do the first derivative now?
To reduce it, we can get, think, dx.
Are you sure? Are you sure dy equal to dt? dt, are you sure dy dt equal to dx dt? Are you sure?
No, I think there's
No,
more to it.
there's no
dy.
such simple relation. Oh, you want to use yeah, you want to use dx. You want to trying to work out the yes, that's right.
Mm-hmm.
But what is now the question began? What is dy dx? Good question. What is dy? What is dy dx then? Is this question come from your textbook or you copied from other reference?
I copied from
okay, other reference. Okay.
To get dy dx, you.
Oh, in other words, you have to find a relation between. That is the question. What is this equation? What is the relation between y and x? See, that is the question I asked you. You see.
Mm-hmm.
Without this relation, we cannot find this first derivative, right?
Yeah. So do we first figure out what the volume of the cylinder would be?
You have to find the relation between x and y first. Yes. Pi 10 square. Oh, we don't. Do we have to use this number?
I think so.
That is in this case that is.
I don't know how to get rid of the volume. Otherwise,
no, the volume is constant. The total. This volume is different. Can you see?
Mm-hmm.
This volume at this moment is at any time. Can you see this volume at any time? Can you see? And that volume is special numbers is when that is when that is a conditional. Can you see? That is when y equal to 10, x equal to 5. That is a special value. It's constant. Just put it this way, when water level change, the y change, right? And also x is also changed. Do you agree? Yeah. So when y they are both changed. you have to find a relation between these two variables.
Oh, here the volume would be half x times y.
Half x. Yes, go on. What do you mean half x? How do you know the half x? Yeah, it's a good idea.
This
Y equal to half x.
half xy.
Can you write the equation?
Because this is a triangle.
It's a triangle, yes. X, yeah, equal to, what is V?
V.
Volume. Are you sure equal to the volume? Volume area is area. Well, this area, this triangle, this area, not as a volume. This area.
Oh, then it's the area.
Cannot, yeah. Maybe I need to draw another diagram to help you to see that relation. Very simple, this relation. Can you see? If I draw another diagram, maybe you can find it out. So basically, we know that this time I simplify this column, right? I just found the dependence between x and y. Can you see? Can we use the color? Can we use this purple color? Can you see? We are interested to find this relation. One moment. We need to find this relation. Can you see? Or I just put the purple color here. So what is relation? How do we describe this straight line? So this is y. At any position, this is
y equals
x and y is proportional. Can you see? So what is the slope? Y equal to k multiply k. Right? Do you agree? And they give you a special angle here, a special number here. That is a 510, right? Can you solve this puzzle now?
Oh. Dy dx equals k.
What is k?
Dy dx?
No, k. Well, if you don't know k, what's the point? You cannot use k. K is later. K is not a number. What is a k?
Oh, it's the gradient. The slope.
Yes, that's right. That's a gradient. So what is the gradient of this straight line? So this is origin.
Oh, it's 2. No, not 2. Half.
You can work out. You can work out the gradient. Yes. Yeah. How did you work out? By the way, how did you work out the k as a ratio?
Because k equals y over x, which equals 10.
Yeah. That's right. Yeah. That's right. That's right. So this is spatial. Can you see? This is not this is spatial. This is height and radius. Can you see? It's height and radius. All right. So we found this relation. Can you see? Yeah. And we also found this radius gradient. Can you see? Okay. Can you solve this puzzle now? We got yeah. Sometimes you need to draw the proper diagram.
How do we? I don't know how to get the volume though.
Well, we got the formula now. Do you agree? Can we just rewrite this formula here? Can we just jump from here, right? I will use this area to solve this problem. So basically, we know that the volume, just a cylinder, as a function of time, right, is equal to 1/3 of y multiply pi. X can be replaced by half y, right? Square. Can you simplify this formula now?
Oh, yeah.
Yes, that is the formula you need to use.
Um,
Yeah. Cubic. Yeah. Cubic. Yes. Okay. So we got this function. Bear in mind, y is also the function of time, right? Maybe let's go to next page. So from previous page, we got this formula. So when you solve this type of problem, you need to find the formula first, right? Which is pi 36 y cubed. Okay. What can you do next?
Then we can get, oh, wait.
So both volume and y are changing, right? Function of time.
Yeah.
So what can you do? So just bear in mind, y is also the function of time as well, you see? And how do we find the dy dt is a purpose, you see? Can we use calculus now? Can we apply the calculus now?
We can find dy over dv.
Dy dv? Ah. V is volume, right?
Yeah.
Why? Why do we need from this derivative?
So that we can figure out dy dt by doing dy dv times dvt, which we already know, which is
which is constant, right? So what you're trying to say, so dy dt?
Yeah, so if we find y in terms of v equal to
oh, you mean this part, this term is you given, right? That's good. Okay, this is equal to this number, right? Oh, you solve that. Okay, you solve the y.
then dy dv equals the chain rule.
Yes, dy dt, dv dt, yes. Yeah, chain rule, yes. What is index?
What? Oh, that's because it's the cube root of 36v over pi. I just put it in a version that's easier for me to use.
No, what my question, what is the number here? You forgot. That is the number here.
Oh. 403.
Yeah, that's right.
So that's a dy dv, and I think now we know what this is by doing.
That's right. Okay, go on. Yeah, everything is based on the we have to first work out this relation first between volume and y. So you work out as a dy dv, and you forgot the number. You didn't. Yeah, that's right. V is a independent variable in this case. In this case, you have to work out the formula for V, right?
Mm-hmm.
At that height. Okay, right. Where is V now? This V disappear?
V is here.
At bottom. Oh, how did you do that from here to here?
Because 36 pi.
No, forget about the CCF. Just focus on this 4/3. Did you rewrite this as that? You can't. Did you rewrite
oh,
this?
wait, I did it the wrong way around. It should be 3
yes.
pi. 3 pi. 3 pi 4/3.
Yeah, it will be the algebra. So V is still where's V?
This is V.
This is V. How can V become denominator?
Because this is 36.
This is V. This is V, right? This is V as well. You get a V.
Oh.
Well,
wait.
I should be still stick with
wait,
in the numerator.
He should still be on the top.
Numerator, yes. Wow, not of pi. Not of 36, not of pi. Wow, 7/3. Pi q, right? Pi q. But how do you know the V apart from this number?
Oh. You don't.
Because V is at any time, not necessarily the final time, right? So you have to use this formula to calculate that V. So you basically I suggest if you want to go this way, we got the V here. Yeah, you have converted the V to Y. Can you see? Can you convert the V to Y? Replace V by Y by using this formula. Because you have the V needed to be determined, right?
Yeah.
Which both of them are time dependent.
I'm not sure how to do that.
Yeah, you can do in principle, but it's very tedious, right? Because you have to reuse this formula to find the V. Can you see? You just you got V here, 36, just pi over 36. Can you see? Multiply the YQ. It's straightforward, right? You got 3 pi, right? You got a fraction. Do you have fraction? 10 over 3? I can't see. Is that 10 over 3? Oh, to the power 10 over 3, right? Oh, this pi over 10 over 3. So that's it. So that's it. So they can cancel that. Can you see? Can we simplify this? 6 canceled, right? And you got something like you got YQ. Can we just put the YQ at last, right? YQ. I just use same color. YQ, and we got 3 divided by 3. How about pi? So pi is 1 take 3, 10 over 3, right? That'd be 7 over 3, right?
Yeah.
Wow, you got it. dy dt dv. Okay, what can you do now? That is a derivative y with respect to v. You can use your formula now. Can you see? You know this now. Can you see?
Yeah.
What can you do? All right, so this second term is just number, right? So how about y? What is y in this case? What is y in this case?
5.
Yep, 5 meters. Yeah. Yeah, you can find this rate now. dy dt.
Think.
Pi is 12, 100.
Oh, I got rid of the pi. Let's see, 125 pi.
Yeah, that is 100 pi. Okay. Yes. Yeah, a little bit complicated, right? This moment. But it's a number, right? It's a rate now.
Yeah.
Can we use a different method to double check your result? Now, I will not go that. I will not use this chain rule. What I do, can we just write this as, can we say V? Can we see, can we just V, can we start from here? V equal to pi over 36, y to the power of the 3, right? Can we just do the first derivative on both sides with respect to the time? Then you got this number immediately, you see?
Yeah.
Do you want to do this way? Can we do the first derivative with respect to the time? Can you continue? Instead of go that chain route. Can you continue, please? Yeah, put this number. You can put this number in front. Yes.
That's dv dt.
Not yet. not yet, because y is a function of time. So this is implicit function. This is implicit function of time. Both v and y are the implicit function of time, you see. That's why we can invoke this first derivative in the first place. We know they both are time dependent. You miss out something?
What is y?
You have used the chain rule, can you see?
Mm-hmm.
You have used the chain rule. So this is the whole thing. Can we call this is can we call this u, ut? Can we call it ut, right? And so u is equal to ut is equal to u, y, and t. Can you see? Therefore, du dt, you have used a chain rule. You have used du dy and dy dt. Can you see? This is what we discussed last week. Do you agree? All right. So anything you're missing? So you got this. You certainly got this du dy here, right? I can notice that you have found this du dy already. Can you see? If we just call this du, this is u, right? You got the du dy. But what dy dt is what we're looking for. You see, you don't have to go further. Dy dt is are looking for.
Yeah.
In other words, so this term. Did you notice that? This is what you got. Maybe you mix the constant already. It's a bit confused. Can we just put the constant outside first, right?
Yeah.
Can we put the constant outside? Then we can follow the track. Can you see? So inside will become du dy, and then dy dt. Dy dt is what we're looking for.
So how do we find that?
Well, u is simply equal to y cubed. So what is dy du? Sorry, du dy?
3y squared.
Yes, 3y squared. Can you see? If you just don't mix these numbers, you can see the track. Can you see? That is 3y squared. Okay, what is dy dt?
How do we find that?
That is exactly what we're looking for. In other words, this is unknown. This is to be discovered. Can you see? To be calculated. And this is a given. Can you see? This is a given. Can you see that? In other words, can I write a question for you here? So by doing so, what we have obtained is that dv dt, right, is equal to this. This is a simple relation. dv dt is a constant. Do you agree?
Yeah.
So therefore, we only need to solve this dy dt from this equation. Okay, this is method 2. Can you follow me? What is dy dt?
Oh, it's 2 meet 2.
So this is 3. Can you can simplify? This is 1, 3, right? So that equal to, if you divide everything, can you find this formula here? You got 13, right? You got 13 divided by pi, right?
Yeah.
Divided by y squared. So my formula is different from yours. That is dv dt. Can you see? So what is y? What is dv dt?
Wait, why is it 13?
You divide it by 3 or 2. Sorry, 12. 12. 12. This is 12. Yeah.
Yeah.
Divided by 3. Yeah, 12.
How did we flip the thing?
Can we just move this to this corner? You see? So we got dv dt equal to pi over 12 y squared dy dt. Okay, to solve the dy dt, we just divide this. We divide this, right? This is unknown. Can you try? Yeah, dy dt. That's right. Productivity. You dislocated. You should be stick that as a read. DVDT should stay together. This looks more complicated than necessary. Can we stick that as a one quantity?
Yeah. Oh, okay.
Yes. Otherwise, how can you use the given condition? Okay, it's different from yours result. Can you see? You got 12, but you got 100 over pi. This is quite different. So you probably have you double check your calculation.
Yeah.
And this is simpler as well. Do you agree? So you just treat this as implicit function. You see, we don't have to solve this dy dv. Too complicated.
Yeah.
Because once you do, can you see? Once you do the first derivative, this become constant. Can you see? This is 2. Can you see? So this method is faster than yours. All right, simpler and faster. Okay. Wow, it takes long time. Do you want to go to another question then?
Yeah. Could we make up a question?
Make up question. Similar question, right?
Yeah.
Yeah, you need to find the relation. So let's just go to this. Have we tried this? This is a simpler question. Have you studied this scenario? This is wall. This is wall. Can you see? This is wall. This is ground. And you have netters. So someone says the workers have netters, which is a fix. Can you see? So this length is given. For example, this length is called L. Can you see? L is equal to say 5 meters, right? And they are both sides are slippery. Can you see? These two are slippery. So for some reason, so if the workers climbing the meters and they found this side drop, falling down. Can you see? So this chemical is a P. Chemical is point P. And this is the intercept called Q, right? And this is dropping. So this is dropping, the falling down. So this is the rate, how the fast, the time rate. Let's just use the proper notation. This graph here. This rate, can you see? So this is falling. P is falling, right? And we are interested to know that how fast is this point moving. Can you see this case? Yeah. This question is given. So this is a condition given. Ooh, the same color. So given that the rate of the P, can you see? The rate of P, can we say use V? Can we use V? Point P is equal to say it's dropping. Okay, it's dropping. And they need to know when this arrive at these 3 to 5 meters, can you count 3 meters? So at this moment, this is can we call it 3 meters height? Okay, and the question is the question. So if the rate is this is at height 3, right? And 3, and that if that rate is meters, 1.5 meters per second, what is the velocity of this point Q? at this particular moment? Yes, do you want to try? This is a similar question.
So
1.5, how do you know?
because that's the rate.
The rate,
well, we know that.
so can we just highlight this point, all right? This point is, can we use the red color here? Can you see this is 1 point, that letters. This is another point, Q, can you see? Can you imagine that when the letter is slippery and these 2 points will move? One is vertical, another is horizontal. So how can we work out this horizontal velocity? How can we write the equation first?
So we know
that. When you say VPVT, what do you mean? VPVQ we are looking for. Yeah. Oh, that's an acceleration. dVdP is acceleration, right? We are not interested in acceleration. This is acceleration, right? Acceleration.
So we know that.
No, this is constant. We're not necessarily constant, but we are not interested in the acceleration. We only need to find this VP, you see. At any time, can you find the formula for VP at any time? So that is the question. How can we know? So this is given. Can we find the formula? Can we find the formula V as a function of the VP, sorry, VQ rather. What is VQ as a function of time? Do we know this formula?
No.
So can we find it? Can we find it? This is a typical question, similar to the one we discussed. Look at the triangle. What can that tell us? Right angle triangle. Why do we assume that the length of letter is 5 meters? Does that help? Is that useful? Is that
not really?
Useful? Not really.
Oh wait, no. It's
no.
useful because we can figure out the side.
Yeah.
We can figure out this height, I think.
The height. You can write a quick question. I can see. You can write a question. Yes. So how do we denote this height? In mathematics, you have to know how to pick up, you have choosing the coordinate, right? Do you remember in the previous example, we choose X and Y? Can I give you a clue? Can we just choose this as X and Y? It's a perfect opportunity to choose this Y. So in other words, yes, that's right. That is relation between the, that's right. So that is the relationship between, that's good. It's very useful. Between X and Y, yes. All right. So in this case, so these X are the function of time, see? Both X and Y are function of time. You see? In other words, they are implicitly function of time. Do you agree? So by definition of velocity, how do we denote the velocity of the VQ? Well, how to divide dP? What is velocity in physics? After we studied calculus, not distance. What we started as is
Displacement
dy.
over
No,
time.
dy dt now. Can you see?
Mhm.
But because it's falling down, we have put a negative sign here. Can you see?
Yeah.
Okay, what is a VQ?
Dx dt.
Yes, can you write down? You can solve now. You can solve it now. Okay, so in this case, this is given, right?
Mhm.
This is equal to negative, is downward because it's downward is negative 1.5, right? This is given meter second. So what is relation? So this is relation, can you see? Good. This is a relation between the two variables. So what can we do?
We can figure it out using the chain rule.
You can apply, yeah, you can use the chain rule if necessary. Or can we just use the method for explicit function derivative, formula for differentiation for the explicit function, because both x and y are explicit function of time. So you're going to do this one? No, I don't. You can, yes, you can. dy dt, dq equal dy dt, dx dy. What did you do? How did you do that?
Because
dq is dx dy, right? Or you multiply dy. Okay, dy dt. Yes, that's right. Okay, fine. You can do this one. Okay, go on. What's the dy dx? Dx dy.
That's
Yeah, that's a relation between x and y. Oh, do you want to solve that? Okay, fine.
since this is x, then dx
yeah, dy
dy equals.
You don't have. I just interrupt you. You don't have to solve that because you have. You know the new. You know the new tricks now. Can you see? Can we start from here? I show you. We just know that they are function of time. So why don't we do the d dt directly? Do you understand? Equal to 0. Can you follow me? So what is the dx?
Oh, yeah.
Yes.
So d
Yeah, you can work out the dx square, dx square dt directly. Bear in mind, x is function of time, you see? Both of them are explicit function of time. You simplify too much.
Oh.
You can see, can I show you from here? You got 2x and then dx dt, can you see? Don't forget this factor because x is a function of time, can you see?
Yeah.
Also, the second term is 2y dy dt, can you see? Equal to 0.
Oh, and we know what that
then
is.
you can solve. Can you see what is the d? Yeah, how do we solve dx dt? Can you see? We need to find the dx dt. We need to find dx dt. So this is our VQ, right? And this is our negative. Can you see? This is our negative. Oh, what is 1.5?
Because that's dy dt.
dy
oh, it's
dt.
just 1.5, isn't it?
Yeah. We know the y. We need to find the x rather. Can you see? But can we solve this first? Can we solve that? dx dt is equal to negative, right? Equal to negative. We cancel the 2. That is y divided by x dy dt, right?
Yeah.
This is equal to negative 1.5. So therefore, that equal to negative 1.5. And y is 3. What is x? Oh, you use the Pythagorean rule, right? What is So you
Oh.
have triangle, this is 3, this is 4, there must be 4, right?
Mhm.
This 4, right? X 4.
Yeah.
That's it. Did you see? We solved the problem now.
Mhm. Oh yeah, and we can just figure out v.
Yeah. So at the y equal to 3, x must equal to 4, right?
Mhm. Yeah.
All right. Here is the solution. Have fun. Okay, save that and stop sharing. Okay, see you next time.
Yeah, I'll see you on Friday.
Okay.